So hello, everyone. Welcome to our webinar on introducing 1E for device refresh. And thank you for taking the time to be here with us today. So my name is Alex Webb. I'm a technical product marketing manager here at 1E. And joining me today is Jason Keogh, 1E's VP of Solutions.
Cool.
During today's webinar, we will be starting with an overview of 1E. Then we'll be giving you an introduction to 1E for device refresh. Jason will then give a demo of the 1E for device refresh solution, and we'll close things out by covering any questions that you all have. So be sure to send us any questions in the chat, and then we'll get to them either during or at the end. We're going to have a survey sent out at the end as well. So that's after the Q&A, after we close things out. So please stick around for that. Right, so to introduce 1E, I'll first start with our purpose. At 1E, we reimagine how technology serves people and create new ways for IT to shape the future of work. So our passion for providing a better digital experience is really what's been driving us to build these new solutions for you all to help you work wonders. We deliver value to both employees and the enterprises that they work for. The first value is better experience. We help ensure a frustration-free employee experience that increases loyalty and role satisfaction. Employee attrition is reduced and employee downtime is minimized due to optimally functioning devices. More secure, we help reduce the risk of security compromise by ensuring that devices remain compliant. If a risk or compromise is discovered, then we can initiate a real-time change upon the devices to limit that impact. And lastly, business aligned. We help your employees drive revenue through their activities and the customer experiences that they're delivering by having a better digital experience. We also help the management of costs associated to device support, software asset investments, and of course, device refresh, which is the topic of today's conversation. If you're responsible for the renewal, replacement, or optimization of hardware assets, then this is a solution for you so that you can proactively manage your hardware. The result is reduced cost, reduced carbon impact, and appropriate allocation of devices to ensure that there's employee satisfaction and reduced downtime. 1E for device refresh reduces your hardware expenses, but at the same time, we're going to provide you with the best possible digital experiences for your end users. So this means that device purchase decisions are no longer going to be driven by things like random device issues popping up and causing you to have to unexpectedly make a new device purchase. And those decisions also aren't going to be dictated by age-based device refresh cycles, such as every 3 to 5 years. With 1E for device refresh, you can have a device refresh strategy where your decisions are based on real-time data. So this new solution offers some wonderful capabilities. The first being data-driven recommendations. We do that through device refresh statuses. There are 5 refresh statuses that are available: replace, repair, reimage, reassign, and retain. So these are all going to be determined by performance, responsiveness, and stability metrics. Financial and carbon savings insights. We display the costs and carbon savings directly on the dashboard so that you can easily report on those metrics. The advanced dashboard then is a real-time dashboard. It's displaying the statuses, the savings, interactive graphs, device details. You'll see all of that more in the demo. Custom configuration is the status names, the rules that determine the statuses, thresholds within those rules, categories of devices, such as if you want to group those devices into departments, and much more is all customizable within our solution. We ran a poll on LinkedIn asking people what capability they're most excited about, and 55% of respondents are most excited about data-driven recommendations for improving their device refresh cycle. So this was exciting to us because this is the basis of our solution. Data-driven recommendations is really what this is all about. That's what's going to change up your device refresh strategy and have the biggest impact. So I'll now pass things on to Jason, who will talk with you all about how we got here and do a demo.
Hi all. So there's two elements to this. Okay, the first one is how did we get here with regard to, please stop fighting me for my mouse, Alex. Stop remote control. How do we get here with regard to the concept of solutions? I'll just touch on that first of all. So 1E has software, and that software has modules. It's a platform, etc., etc. What's a solution? A solution is when we're speaking to our customers and we find a recurring business problem, and we figure that we can build a solution to that problem from the existing functionality that we have within our product sets. Okay, so without writing new code to go and get new things. Now, the product and the platform as a whole is extensible. So we basically write extensions to go get that, and then we build out dashboards and different ways to understand the data and maybe control things and subset things, which you'll see in a second, to define what we now call a solution. And this solution is focused on device refresh, and how it was identified was that we spoke to customer after customer, and many of our customers were using our product for device refresh. However, they weren't necessarily doing it in a great way. Everyone wanted to save money and not buy machines when they didn't need to buy machines. Everyone wanted to be more sustainable and, you know, not suffer carbon impact cost when you don't need to suffer carbon impact cost. But there was, you know, fewer and fewer of our customers were actually renewing on the basis of, or refreshing devices and buying new devices solely on the basis of a device reaching a certain age. The machine is 3, 4, 5 years old. Let's get Bob a new machine. Maybe Bob doesn't want a new machine. His machine, which he's had for the past 4 years, is fine. It's working fine. To get a new machine is going to, you know, distract him, and you know, it's going to not necessarily improve his productivity in any way. It could do the opposite, actually, while he struggles to get to grips with all the changes on this new device, etc. So, you know, to just automatically replace it without any real identified need isn't maybe the best way to go about doing it. So organizations realize that maybe that, you know, they don't want to buy machines and spend the money inefficiently. They don't want to disrupt users. And a lot of them had started just already not auto renewing, but they were doing it. They were then making decisions as to which machines to buy and who to buy or get new machines for based on various things. For example, squeaky wheel syndrome, where the squeaky wheel gets the oil. What I mean by that is the users who complain the most get a replacement device, but it isn't necessarily that user that needs a replacement device first. It could be another user who doesn't complain as often, but it's just you know, needs it more, but is just a bit less vociferous about that. So, you know, what we want to do is to base decisions on good, solid data and rationale, and indeed be able to describe that to customers as well, to your end users, to say, look, the reason we're going to allocate a new machine to you is because of this, 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 or the reason we're not going to allocate a new machine to you is because of that, that, and the other. So I'll show you all that in the product. Goals: reduce hardware cost, reduce carbon footprint, improve that health visibility so you can identify the machines and the users that need the machines changed sooner. Match the best device to the user's requirements so that we're, you know, making sure that people who have a need for good hardware have good hardware, and people who don't need as, you know, industrial, as serious a strength of hardware don't necessarily have it. So we're reducing costs by doing that as well. And overall, we want to decrease user downtime. One thing we found as we started getting into this is that some of our customers, of course, lease rather than purchase their hardware. Still a huge amount of value from this solution where that's the case, because what they can do is identify problems and bring those to the attention of their leaseor, the vendor that they're managing. For example, if you've got machines that have hardware faults and you want to get them repaired, you know, the person that's leasing the machines to you, that company is not going to reach out and tell you that, you know, Bob, Tom, and Mary's machines all have battery issues and need to be repaired. I have no way of knowing that in any real way. So with this, you can know it. It can highlight the fact that a repair is required, and you can go to the vendor and get those repairs while it's within warranty, while it's within the lease period, and essentially reduce your need to buy additional machines because of machines that are faulty or being replaced or whatever. So it's a much better way to go through it. I'll run through these when we get into the actual product itself. I'll talk you through each one of these statuses. So let's go and get into the product. Alrighty. So this is device refresh. What we're looking at here is a dashboard that sort of is the accumulation of a number of different things, rules that have been run and statuses that have been assigned. To touch on those statuses, as you can see here, we want to keep machines in the retain status as much as possible. That just means keep, right? There's nothing wrong with this machine. The device meets all model norms and persona requirements. Keep it. Machine is fine. We want as few machines as possible in replace. Replace means it is unsuitable for any user. Get rid of this machine. It's not good. Then we have, in order to, keep machines in retain, we might want to repair them. We might need to re-image them, or we might need to reassign them. So there's no point reassigning a machine to a different user if it needs to be wiped and reloaded and re-imaged. There's likewise no point re-imaging machine if it has a hardware fault. So these are in this order because this is the logical order for them to be in, essentially. We put machines into these statuses based on rules. So let's just have a look at those rules before we go any further. So essentially, this is all of the rules for each of the statuses. So we can look at repair, for example. We'll repair a machine if it has a certain number of predictive hard disk failures. It has a certain number of, or its battery is at below a certain threshold, or it has a number of, excessive number of overheat related shutdowns or whatever. Each of these rules is editable. So I can click on a rule and say, actually, I want, if that happens more than 5 times in a week, I think that's, enough for me to flag it and want to have a look at the machine and consider it as needing to be repaired. So I can update that rule. And then the rule for repair now says 5 times rather than 10 times from that. Any of the rules that are not default, I can edit pretty much. I can delete them. I can change the name. I can do anything I want on them. The default rules, I can't change the name on. I can change the threshold. So I can modify the settings relating to default rules. There's a few default rules, as you can see. But I can't, delete them. It's a default rule. You can flag given models to be replaced. So, for example, you've identified that Model X is not compatible with Windows 11 and you're moving to Windows 11. You flag the model to be replaced and it will automatically get moved into the replace, category, any machine matching that model. You can disable that rule if you don't want it to be in place, but you can't delete it. You can't change the name. If those default rules have thresholds, like there's one for consider the device to be, for example, if an excessive number of incidents are raised in a period, we can change the period, right? Or if we want to look at another default one, we have a device below the model average. So we want to consider devices and say, look, well, maybe we need to re-image this device if what? If it's below the model average. So what does below the model average mean? We look at some of these machines that are marked for re-image. So, when I click on any of these, it automatically filters. So as soon as I click on that, I can see that all the machines that need to be re-imaged are Dells in India. They're spread across 4 of our departments. I can click into that and say, well, show me the 8 which are in engineering. And it drills in. And every time I drill in, the grid down below updates to show me what that is. And I can see that it comes up here as well. So I can say, well, show me everything that's in engineering all around the world, regardless of status, and it will change to that. Or show me all of my machines again and change it back to that. I can drill into Dell and it'll show me which models are most common for Dell, drill into a given model and it will show me how much RAM I've got in different models and things like that. So essentially, we can keep on drilling in and drilling in and drilling in until we get down to the set of machines that we want to look at. But enough with my cool clicky drills. I do think it's actually a really nice way to navigate data. But if we want to look at those machines that need to be re-imaged, for example, again, those Dells in India, we can go into a given machine and we can have a look at, whether it's a good or a bad machine. What does that mean? So we're talking about whether the machines are significantly above or below what is average for that device type. So this is a Precision 7920 tower. I'm sorry, I didn't mean to click on the model. You can also go look at the details per model. And we can see that, this is the average machine in 1A. this is how long it takes to boot. And we had a spike in boot times back in November, but generally speaking, it's low-ish, and we're about 78 seconds boot by norms. This particular device is right in or around there, right? It's booting in 71 seconds, so it's just below the average. And the model typically boots in 61 seconds. So the machine is slightly slower than the model average, slightly better than the overall average. This is a bit of a beast of a machine. It's got a Xeon processor in it, so a bit of a monster with 64 gigs of RAM. But basically, we can see that this particular machine is performing significantly below the live consideration for combined score. So what's combined score? If you're familiar with the Money platform, we gather a lot of what are called responsiveness metrics. And these are create file, create process. You can read there, disk, so it's basically processor, disk, memory, network, even read and write registry. So we're measuring all of these things, and we essentially create a score out of that to say, is the machine good or bad? And you can see that has fluctuated over time, somewhat across the board, but for the model and for the device. Right now, the model is at, it's got a negative 0.49 score, and this device has, and the average machine is like positive 0.92. So like it's 3 times worse than the average for this device. Or this device is 3 times worse than the average one of these models, I should say. So this device is not doing well. Okay. Given that this device is not doing well, we're saying, well, it might get better if we re-image it. And that's something we can look at. We can actually see that probably the biggest variance here is relating to the process responsiveness, which is specifically the area around creating threads and creating windows and so on. So you can get into the technical details in this. Indeed, you can see all of the raw data if you really, really want to go there in terms of how many milliseconds or nanoseconds it's taking to find a file on the disk or whatever. But ultimately, we wrap them up in these scores to make it easier to understand, and then you can understand comparative to the average, comparative to the model. The model typically, are these machines in a good or a bad way, and then essentially you can go in and identify which ones need to have some attentions paid to them. I mean, this device is getting significantly worse. For example, there's another one here. I think that's a different device. I clicked on the same one accidentally, but was trying to go into a different one. So we can drill into an individual device. We can also understand things on a model by model basis. So if I look at models, I can see I've got lots of data about machines here, but I can, let's say, all models. I want to see that category. So now I get a scatter chart showing me how models compare to one another in terms of how fast they operate across that combined score, or how quickly they boot is the bottom one here. You can categorize different categories of machines. So manage model categories. I created this list earlier of ones that I'm interested in. I just called it interest. You can create your own categories. You can edit the categories. You can put machines in and out of categories. You can do whatever you want to do. And when you've done that, you can then do things like show me those machines that I'm interested in. And we'll compare those machines against one another. And we can actually see which machines are performing better or worse than other machines. And we have the full details down below of that, right? So we can sort them by CPU or whatever. I see actually we've got a few machines with this CPU. So we can click on that CPU, and now we can see we've got a HP and a Surface, Microsoft Surface. They both have the same CPU. Interestingly, the Surface with less RAM is actually performing better and has a faster boot time as well than 92 seconds instead of 106 seconds. Not that big a difference than the HP. So it's interesting to see that. Now we can also see there's only one device there of each, so it's very small data. This data averages itself. The more devices you have of that type, the more accurate the data is going to become, because it actually averages out over time. You can also see that there's costs associated with the models. I mean, you can add cost in if you want to. So this particular model, it's got a category estimate for cost. It doesn't have a real cost associated. So we'll say that one is, I don't know, $3,000, $3,050. And this is a 380K. You can get the carbon cost of a machine from the manufacturers. They have what's called PCF, product carbon footprint data. We're actually in the process of going and getting that data for a number of different models, and we'll have it pre-populated in a lot of cases. But essentially, we can grab that data, and then we use that either as an overall estimate. There's a balanced weighting of 326 kilos of carbon per machine. Why 300 kilos of carbon for a machine that weighs 2 kilos? we literally, the measurement that the manufacturers do comes from when you start digging the rare earth minerals out of the soil to make the battery, to mining the aluminum to make the case, to building it all and manufacturing it all and putting it into a box and shipping it from China to wherever it's going to. So that carbon average is literally the entire carbon footprint of all of that. When you look at regulations, I think that's called scope 3 carbon consumption, and that scope 3 carbon consumption is something that companies want to get a handle on, because next year any business that has any operations in the EU will have to report on those numbers, scope 1, scope 2, scope 3 carbon consumption, and essentially that report can have impact on things like investor relations. So essentially the Dutch National Pension Fund recently pulled $30 billion worth of funding from companies that had high carbon footprints in order to invest that same $30 billion into companies with low carbon footprints, because as a nation, they want to encourage companies to have lower carbon footprints. So when it comes to considering which device to purchase, well, maybe devices that have lower carbon footprints will be more interesting, even if it's slightly more expensive. I actually remember looking at this data and seeing that this Surface Laptop 5 is faster and behaving better, for example, than this Surface Laptop Studio, even though it's a more expensive, the Studio is a more expensive machine. So the cheaper machine is outperforming the other one, and it actually has a lower carbon cost as well. So when you're trying to make informed purchasing decisions, data like this can really, really help you. Which model type should I buy? Typically, organizations will categorize models as being, sorry, there's no executive laptops, which are Microsoft, that did that. They will categorize machines as being in different statuses, like exec laptops or these models or whatever. When you do that, and then you want to make a decision as to which models to take going forward for the next year, this sort of understanding of the carbon cost, the dollar cost, and then the performance of the devices comparatively can be really, really powerful set of data to make better decisions. And what we're trying to do here, again, remember, is to fuel better data-driven decisions when it comes to managing device refresh. So we have our rules that categorize machines into, this machine needs to be repaired, because if we look at the repair here, all of these machines will have low battery health is why. Well, most of them, that machine needs to be repaired for some other reason, so it's probably got hard disk failures. The rest of them are all low battery health. And you can drill into the machines, by the way, get those details, but you can also see the history and figure out why it's been set to the, so battery health issue, currently 35, which is below 60, setting it to repair. Okay, so it tells you why it's associated a given status to a given device when it goes through and runs its thing, and you can see what events have happened across the lifetime of the machine when it's triggering events as well. So those events, by the way, those rules, if we jump back into those rules, essentially we can have a new rule. Let's have a look at, reimage. What do we reimage on the basis of? We reimage if the device is significantly below, in this case, 30% or more below the model average. We reimage if foreground apps are crashing repeatedly, so 15 times in 7 days, or if background apps, well, most customers don't really care so much about background apps, so we'll make that 200 times rather than 20 times. So that's like if McAfee is crashing in the background, the user doesn't really care so much. However, if Teams is crashing or Outlook or something they're using actively, they'll care more. So you can actually monitor those and create different rules based on those. Or if we have the OS blue screening, for example, any of these things are going to lead us to say, look, you might want to reimage those devices. And then replace includes if you've reimaged the device too many times. Okay, so you've basically reimaged the device more than 5 times in 90 days. Well, in that case, maybe you want to change the text in those as well. Reimaged too often. So we can, we can basically edit all the settings, edit all the different criteria as to what makes a machine go into a different status. And we can add new rules. And those rules, so demo rule, can be based on events. So for those that are familiar with the 1E platform, you'll be familiar with the concept of automation rules in the 1E platform. So we have automation rules that monitor for excessive CPU load or hard disk failures or software crashes or whatever it might be, all those different events that you can see there. And when those events occur, it sends a message from the 1E client on the endpoint to the 1E platform server, which sends a message across to this solution API, which says that Bob's machine has had, I don't know, excessive CPU load or whatever it might be. And then we check to see if it's had it more than the number of times in the number of days that we've said, exceeding the given threshold that we've defined. And if that machine breaks that rule, then we set it to the status that we've defined as the status we want to have happen when that happens. Okay, so we can add those rules, we can delete those rules. So there's demo rule, I can, you know, modify it, I can delete it, I can do whatever I want to, you know, to manage those rules. So essentially, what we've built here is a system that allows you to define rules based on many different things. So we've looked at several of them. We haven't looked at the reassign logic yet. Reassign is when maybe devices below or above persona requirements. So we'll look at that in a second. Or if we see excessive CPU load or high memory usage repeatedly on a machine over a period of time. So that indicates that the user is sort of grinding the hardware. The user is like really, really ramping up the use of the CPU, ramping up the use of RAM. And by excessive, what we mean is for a 10-minute period or more, it exceeds 95% usage. And it's done that 10 or more times in a week. That user is really, really hammering that CPU. Maybe their machine isn't good enough for them, and we want to give them a new machine and get them a better CPU, and then they can be more productive and happier and so on. Equally, you could have a machine which exceeds the persona requirements, in this case by 60%. So we're saying if it's below persona requirements, and we'll look at what they are in a second, by 5% or more, flag it. But if it exceeds it by 60% or more, flag it. So what are persona requirements? We can take users and categorize them into personas on the basis of different rules. Okay, so we basically have a list of users here, but we can say, well, who's in engineering? These are the users that are in engineering. Why are they in engineering? Well, because their host names contain these particular structures. Or we can have a new rule based on something else. Tags, we can put a tag on a device with the 1E client based on anything that that device can tell us. It could be an AD group membership. It could be whether a given piece of software is used on that machine or not. It could be almost anything. And you know, if that tag is present, we could say, well, consider if you're using Visual Studio, consider the user to be in engineering, for example. Or you could say, well, we want to create a persona type called resource demand. You can create your own persona types, your own personas, and we want to consider you to be a power user if your user is in engineering. Then you're also a power user. You're a standard user if, well, I haven't got any rules set for that. You're an efficient user. I've just set up test here if your host name contains US, right? So we can define whatever rules we want to basically identify machines as being in any given set of persona types. So a user could be in department engineering and you know, resource demand, power user, and work style, home-based, and employee grouping, director, and test users, yes or no. Okay, so when we define those things and assign those users into that, we can then see over here which departments or resource demands or whatever different people are in. Okay, so we can then drill down based on the basis of those persona types. We can also define for a given persona type some persona demand rules. Okay, so I've only given them to the resource demand because that's kind of what I created this one for. But you could assign it to any given persona. You could say engineering need this, or you know, different department needs that, or people who work from home need something else. These are the criteria you can say they need. So it's based on, you know, I've said if you're an efficient user, you need at least 8 gigs of RAM. If you're a power user, you need at least 32. And if you're a standard user, you need at least 16. Now, top boot seconds. This is basically a percentile measurement. So, for example, 20% of your score. So we're saying if you're a power user, we want your machine to be in the top 20th percentile of all machines, combined scores or process-related scores or disk-related scores, right? We're excluding VMs because they tend to skew it. You can include them if you want to. You can just change that and include VMs or whatever, okay? So essentially, we define our rules and say, this is what we consider a power user's machine should look like. This is what we consider a standard user's machine in the top 50%. And it's saying efficient user here is in the top 95%. So we'll essentially suggest we want to get rid of machines that are, well, because we've set the setting to 6 to 5% below, it doesn't matter. If we set this to 90%, we'd flag the bottom 5% of machines as being automatically for reassignment. So we can identify them and then maybe look to get rid of those machines from the business because they're in the lowest 5% of performing machines, period. And that's probably a good thing to do is to get rid of those. So essentially we can configure our rules, and then when machines are not suitable for the users that are using them based on those criteria, either excessive use of CPU or RAM, or not meeting those requirements that we've defined, they don't have enough RAM in the machine, or it boots too slowly, or whatever it might be, we can actually identify that and flag it, and then you can go in and say, okay, well, show me why we think that machine is needing to be reassigned, and we can say, well, it's below the persona demand setting to be reassigned. So this machine is not particularly wonderful for its user. Let's see how it looks overall. That's pretty average. It's an average machine of its model. It's not a bad machine. It's just that it isn't strong enough for the user that has it. It doesn't have the requirements that we've set for this particular user type. So probably boot slow or something like that. So when we've calculated all of that, ultimately we get to a point where we say, under normal circumstances, and you can define what normal circumstances is. So again, in the status rules, we would say we would normally have considered something end of life if the device was a year past its warranty, or maybe 90 days past its warranty, or whatever you want to set as the definition for that. But often there's a 3-year warranty, and you say you want to refresh on 4 years. That's how we could do that. We can add new rules to end of life as well. We can define other criteria by which we would consider a machine end of life. We can set that with a tag if we want to, or anything else. So we can define end of life in which way we want to. But when we define end of life, all that does is say, under normal circumstances, if we weren't doing things in a data-driven way, we would consider this machine to be end of life. And if the machine is end of life, and it's not in the replace status, or is not already retired, essentially, as well, then we will say that it's a deferment. This machine otherwise would have been considered end of life, and it's currently in retain status, so it's not end of life. The user, it's suitable for the user, and it's being used. So therefore, we've deferred purchasing that, and we've saved the cost of that machine and the carbon cost of that machine. And when you add up those 21 machines, it turns into this amount of money and this amount of carbon. So this is a small environment with just a few hundred machines. It's real data about real machines. But if you can imagine, if you've got 30,000 machines instead of 300 machines, you're talking about looking at hundreds of thousands or even millions of dollars worth of savings, and tens, if not hundreds of tons of carbon offset. Some of our customers are actually looking at ways to take this data and make it meaningful to their business by obviously being able to report in the future on having lower carbon emissions, but B, being able to offset that to see to be able to offset that to attribute the majority of their carbon usage to their core business. So if they are a pharmaceutical company, they want to burn carbon making drugs. If they're a bank, they want to burn carbon operating their banking business. They don't want to burn carbon buying machines that they don't need to buy. And this essentially helps understand and deliver to those goals. So I think we've looked at most areas. Alex, anything I've missed?
No, I've got a question for you. So we saw live data in the device view for an individual device, but this dashboard overall on the table below, that's reporting real-time data as well?
Yeah, so this is pretty static data because it's, the machine is not likely to have its RAM change or whatever. If it does change, it will represent that within, I think, a day. We do that. When we look at a given machine, though, we can see refresh events and repair events and so on. If there is a hard disk failure event, for example, on an endpoint, that will fire from the endpoint to the Money platform and across to this in real time. So where we have devices that have actual events happening that are saying this is a problematic device, we will see those things coming through, and the status will update in real time, and this data will update in real time. So yeah, it's real time data.
And when a rule is modified or a new rule is created, does it pop up immediately, that data, or does it take a while for that data to be collected?
Oh no, when you create a new rule or modify a rule, you can literally just say run my rules. So run rules, and it goes and runs those rules, and it's done. So yeah, if I were to change rules or I think I changed that one, right? So if we had 200 crashes, we'd have more machines as re-imaged than we had before, but I don't think we don't have 200 crashes that often. But yes, as soon as you press run rules, it will run the rules. And otherwise it will run the rules on a daily basis. So it'll run the rules when the events happen. It'll assess, has the number of times this event has happened exceeded the threshold that we have for the rule, and if so, it will change the status in real time. Otherwise, things like battery health or RAM or whatever, it'll do that once a day. It's very unlikely a machine will drop in RAM and suddenly become reassigned because it's got 16 gigs now and it had 64 gigs yesterday. But I mean, it can happen. And that will be basically highlighted the following day. Or unless you press the button, in which case it'll be highlighted immediately.
Awesome. Thank you.
So, I mean, I think the slice and dice functionality is really, really cool to be able to drill into any given thing and then, keep on drilling in and find machines. It's actually, as a reporting interface, as well as just the statuses and so on, but as a general reporting interface, it's fantastic. Plus, you can actually take this stuff and then start saying, okay, I want to, I don't know, I want to group by location. And in each location, I want to know how many models I have. And when I have that data and I like that data, I want to export that to Excel. And then that gives you the Excel file. And then you can open up the Excel file. So you can open in this window. It might, there we go. And it even keeps the groupings that you've done, so that the groupings and settings that you put into I have to select the label, do I? This is fine, it's public. But then you can, it's all of the data that you want is in Excel, and away you go. That's based on the filters that you've set and the groupings that you've set, and so forth. And you can take out subsets of that as well. So if you wanted to just get, I don't know, the data on those 3 machines, for example, or that amount of machines, you can just right click and copy with headers, and then you can stick it into Excel or Notepad or whatever you want to put it. So yeah, for example. Okay, so it's very nice to get the data in and out of and to work with. So any other questions? And if you have any questions, where you're watching from, feel free to type them into the box.
We can go to that Q&A slide, and I do have some questions that came up in the chat that we can run through.
Yep, far away.
All right. So how would you go about preventing someone from artificially impacting their score to try to get an upgraded machine?
Well, if they went in and unscrewed their chassis and took RAM out, that would work, I suppose. But you'd see that pretty quickly. And you can see the changes as well. We saw the device history, so you'd see that it went from 64 gigs RAM to 16. How else could they artificially change it? I mean, you can't easily crash foreground apps. You can try, but that would change it to re-image rather than replace. I can't really think of a scenario where someone could do that. I'd like to meet someone that sneaky as well.
I also think that the average end user might not even realize that this solution is part of your IT strategy.
Actually, a lot of customers will communicate things like this to their end users. And indeed, based on the status that you are at, you can have actions associated with given statuses. And those actions will allow you to do things like log a ticket to find a replacement. This would be a ServiceNow ticket. Others might actually notify the user that their machine has been set as, one that we want to replace, and therefore we want to, get them to choose a new machine, or make sure they've got their data saved off, so when they get their new machine, they're not going to be surprised by that or whatever. So, we can associate actions that can call out to other APIs like ServiceNow, or call out to the OneE platform to message the user and do things, or send emails to users. All of these are possible. So, so users will become aware, or should become aware over time, that there's something there assessing their needs and trying to make sure they have the best machine to what they require. But you wouldn't go into the details of giving them all the ins and outs of what the individual rules are. And even if they had all of that data, they'd really need to be, I don't know, how can they fake hard disk smart failures? Or, it'd be very, very difficult for any user to be that devious, even if they tried really, really hard. I'm very devious and I can't figure a way I'd be able to do it. So.
All right. Next question is, is your data retrieved based on only active endpoints? So if the organization has 10,000 endpoints, but only 5,000 are powered on, will the data reported only be showing those 5,000 devices? In other words, if a machine isn't on, will the status still show in the dashboard? Will the device data be able to be pulled?
Yeah, you'll have the data for any machine that is ever reported. There is the data. The machines go away if we haven't got any data from them for 90 days. We just mark them as retired, and you can go and see the ones that are marked as retired by pressing that button. But otherwise they're just any machine that isn't retired. In other words, any machine we've had any data from in the last 90 days, you will have this status information for that machine. If it's on or off, it doesn't matter. The actions, like some of the actions will restore a previous restore point. They won't happen unless the machine is online. But they will wait until the machine becomes online, then happen if the machine is offline right now. So when the machine comes online, it makes a connection to the OneE platform and says, hey, do I have any instructions outstanding for me? You can have an instruction waiting there to get it to do something based on the status that it was at. You can have actions automatically happen when a status changes, or you can have them happen when somebody presses the nice button and then presses that. That will actually send a notification. They emailed them in this case. So so that's how that works.
Awesome. All right, and is this presentation going to be available to be shown to others within the organization? Yes, so I can answer that. The presentation is going to be, or this is going to be available on demand, so you can send this webinar to anyone in your organization.
So they can hear about how devious I am.
Exactly. All right, so I think that's it for today. Thank you all. If you have any other questions, or if for some reason we missed your question, we'll email you. But if you have any other questions, email us. And as a reminder, at the end, a survey is going to pop up, so please stick around to answer that. And please visit OneE.com to learn more about more ways to work wonders with OneE. Thank you.
Thank you.